Hi, Professor Carrie Miput. Sorry, do I pronounce your name correctly?
It's correct.
Yes, thank you for joining us. I think we have uh, so Prakash, he is traveling, so I will help him host today's meeting. Okay, so I think we can start, right? Hi everyone. Today we are very honored to have Professor Carrie Mipu here as our speaker. Um, Professor Hardis Carrie Mipu is Canada Research Chair, Director of the Smart Cyber-Physical Lab, and Associate Professor in the Department of Electrical and Software Engineering at the University of Calgary. She is the leading pioneer in applying AI, machine deep learning, to enhance the security of critical infrastructure, IoT, and operational technology. Over the past 7 years, her extensive body of work includes over 135 peer-reviewed journal articles, conference papers, and a book chapter with more than 7,000 citations on Google Scholar, which puts her among the top 2% of globally cited researchers according to the Stanford ranking. She was named one of the top 20 women in cybersecurity by IT World Canada in 2021 and received the IEEE Communication Society Early Achievement Award and the APEGA Early Accomplishment Award in 2022. She was also named one of the world's 20 most inspiring women in cybersecurity by IT Security Guru, a UK cybersecurity news digest, in an award sponsored by industry giants, including BT, formerly British Telecom, and KPMG Accountancy. In 2023, she was honored as one of the Avenue magazine top 40 under 40 and received the University of Calgary Excellence Award in Research Excellence, along with the prestigious AS Tech Award in AI/ML Advancement. In 2024, she was named one of the top 10 under 40 by Canadian Security Magazine, the voice of the security industry in Canada for more than 40 years. She also received the Canada's Most Powerful Woman Top 100 award, which celebrates female trailblazers who break barriers, redefine leadership, and make a transformational difference for all. Uh, Thank you, Professor Terry Mipu. The floor is now yours.
Thank you very
Also,
much.
please
Thanks
start.
for the introduction. Thanks for the introduction and thanks for the invitation. And everyone, thanks for joining this presentation. And I hope that you will enjoy it. And thanks for the introduction. I wasn't sure what's the background of the audience, so I tried to make it more general type of presentation. I have a few example related to some of the technical work that we are doing, but I hope that's something that people can learn from. My presentation is focused on the application of AI in cybersecurity and trying to talk about advancements that are basically going around these two buzzwords and technology, and then how we can take advantages of it for cybersecurity. Because my main research, as was mentioned in University of Calgary, is on the cybersecurity. We're trying to take advantages of different technology like AI. Like everyone else are trying to take advantage of it. And we wanted to make sure that the cybersecurity more basically automated and advanced. So yeah, let's begin by reflecting on some of the development that are unfolding around us. We know that right now what's happening around us is that we're not just adapting technology, but we are embedding it in every single aspect of our life. If we look around, we will see that every single devices that we are working with is kind of digitalized. And it's from our smartphone, our home devices, our critical infrastructure, everything is being pushed to be digitalized. Obviously, this digitalization brings lots of advantages with itself, and and that's the main reason that why we are pushing toward it. But at the same time, it will bring new layers of risk, because every single connection introduces new opportunity for exploitation by cyber criminal, and that means we are dealing with new basically level of risk. If I wanted to be basically more specific about the changes that that are happening around us, we can say that in 4 main directions, changes are happening very fast and has more basically impact in the way that we look at the cybersecurity measures and techniques that we use. One of them is related to the AI and machine learning, because nowadays AI is like a core engine of productivity. It's not just something experimental or fundamental. It can be used to make everything automated, faster, easier, which is good for us. But at the same time, cyber criminal can take advantages of it, and they can have automated cyber attacks. They can have more sophisticated cyber attack, and that means if we wanted to basically defend against those with the traditional cybersecurity measures and cybersecurity tools, we're not going to be able to compete with them, because everything is a lot faster nowadays. The other thing is related to the convergence of the IT, IoT, and OT. IT, information technology, IoT, Internet of Things, and OT is what we call operational technology, the equivalent of the IT, which is used in the industrial control system or critical infrastructure, like the way that 2 PLC devices communicate with each other, the way that 2 generators communicate with each other. We would call it operational technology. It uses different operating system, different protocol, which is totally different from the way IT basically systems are working. To accelerate and to digitalize this critical infrastructure, we are pushing them to be basically connected and to be merged with IT technology. But we're forgetting the fact that these infrastructure, they were built like 100 years ago with the isolation in mind. That was a factor when these systems were designed. For example, when Edison was inventing the whole energy distribution system like 100 years ago, he was thinking about sending the energy to a few kilometers away. And that was the architecture that was proposed. Nowadays, we are using the same fundamental architecture, but we are pushing it to be connected to the internet, and it's not ready. And that means there are lots of vulnerability related to this connection when we don't have proper foundation. And again, that's a playground for the cyber criminal that they can easily take advantages of it. The other changes that are happening is that, again, because of the nature of all these interconnected devices, the way that we manage them through the edge computing, cloud computing, fog computing, blockchain technology, all of this is resulting in a decentralized architecture. So we no longer are working in a centralized system and everything is coming to one place and then we can easily manage it. The architecture is decentralized, and that makes management of this system a lot more difficult because we don't have visibility over everything, and that's a big and important issue. So again, this is another major changes that are happening. And then the last one with the quantum computing, we basically introduce a new class of cybersecurity risk, which threatens us to break widely used encryption protocol like RSA, ECC within a minute. Obviously, we don't have quantum computers to their basically full power right now, but in a few years, once we have those computers with enough qubits, what you would see is basically something very scary, that every basically encrypted devices can be decrypted very easily. And again, that could change the way that we deal with this cybersecurity, and will bring lots of new trends of attack. So with all of these changes, we see huge number of the attacks, and it keeps increasing. If you compare the number of the attacks that every year you see in different sectors like healthcare, energy sector, you see that compared to like 10 years ago, we see a high increase in the number of the attack. We had a recent one in US when a major hospital network was targeted with the AI-generated ransomware attack. All the data was encrypted, lots of reputational damage. We had lots of attack in energy sector. We had Colonial Pipeline attack. We had one in Saudi Arabia, and lots of more examples. Ukraine attack, which is one of the basically famous one. And many of these happened when AI was not as strong as it is nowadays. So you can imagine with the power of the AI, what we can expect. And every single day, it's getting worse. And nowadays, we see a new trend of attack when AI models that are used by different organizations are also attacked. So it's like you're relying on AI models to protect your system. And that AI model also can mislead basically your operator and result in a new basically a stream of the attack, which makes the situation even worse. Yeah, so with all these basically changes and promises, we are in an era that we have different tools like AI that is supposed to help us, but it's like a double-edged sword, and a cyber criminal will take advantage of it a lot better. To be more specific, I have a couple of slides that I will explain why AI can be misused and is used by cyber criminal a lot better than us. Generally, when it comes to cybersecurity, we always see that cyber criminal are one step ahead of us. And that's why we're always behind them and we always suffer from cyber attack, because it's like they have different motivation to look for vulnerability in the system to launch different type of attack. And this is the same way with the AI. They're taking advantages of the AI in terms of misusing it actually a lot better than us as experts to take advantages of it to defend the system. One of the basically type of the attack, let's say, or the way that cyber criminals take advantages of the AI is through phishing email. We know that AI tools like ChatGPT is fully automated and require no human intervention to generate its response. So it can be programmed to generate many different response like email, chat, and anything in parallel. And then with the fact that we share lots of important information in the social media, it's really easy for an AI engine to find everything about different people, link them together, and then generate and create customized, personalized email, like a spear phishing email. You know that when the phishing email is sent to everyone, once it's personalized, it's a lot easier for the people to trust on it, and then they will get caught and they will click in the wrong link, the malware will be installed in the system, and the whole story will start. So that's one way that AI is helping cyber criminal in generating phishing email. And the other way that they take advantages of it is that, as we know, most of the cyber criminal are from non-English basically speaking country. And that's common for them to have grammar issue when they're writing their phishing email, and to be difficult for them to write lots of variation of the email. Obviously, they can solve it to pay for someone to help them, to pay for different tools. But all of these means using resources and money, which slow them and reduce the number of the successful type of phishing attack. But with the AI, on the other hand, obviously, it can be automated for a larger volume. And that's what we see. I see with every single person that I talk, they receive many different email, text messages, and lots of different variation of the phishing email. That means the whole process is being automated. When you target a large group of people, it would be a lot easier for you to find a victim. That victim could be one single person that you would get access to their account, or they could be connected to a larger organization. It might be difficult for the criminals to get access to a larger organization with lots of security measures, but it's a lot easier to find someone who's working in that organization and then get access to that systems. Maybe that the person goes to the workplace, they make a mistake over there by clicking a link, or maybe they're working from home with the culture of work from home. We have lots of issue like this. People don't have proper security measures at home with their system, and then they're connecting to the organization infrastructure with their own system, which is fragile. So that's easy point for the criminal to get access to the organization. And again, a phishing email is one of the very first basically attempt that they will make, and most of the time it's successful. Whenever that I talk about phishing email, people always ask me, so this is something straightforward and obvious. So how come we cannot just train our employee and explain them that they should not trust and it's suspicious? So why with all these information around it about this and all this awareness, why still people make the mistake? The answer is that no matter how much prevention we basically take against this and how much we train people around us and our employee, still cyber criminal find a way to make it very, very customized. And specifically when it's a state-sponsored type of criminal that have lots of resources and basically money to spend, they would find something very personalized about you, and that will motivate you. One of the most chilling example of spear phishing basically comes from 2015 or 2016 Ukraine attack. That was the first known cyber attack to cause blackout in a smart grid facility. What happened here was that the attacker sent a Word document claiming to contain news about the recipient's brother who was reportedly serving in Afghanistan. So they sent an email. This is a list of people who are serving in Afghanistan. Some of them are dead. We know that your brother is working there. You might want to check the link and see if your brother's name is in the list or not. So just put yourself in such a situation. This is very, very, very personalized. And the last thing that you can think of is that this is a phishing email. And that was what that IT specialist with high level of access did. Clicking the link, the malware was installed in the system. Cyber criminal got access. They were in the system for 6 months. They were launching different type of attack, a small attack to collect information, and no one realized that someone is in the system. So we didn't have any sorts of active, proactive cybersecurity analysis in the system, and still we don't have that much in many critical infrastructure. So the point is that prevention is not enough, and we will see huge number of these customized phishing email with in the era of the AI. So we have to be prepared more. And the other area that AI helps the cyber criminal to take advantages of is through misinformation or disinformation generation, social engineering type of attack. And again, that's related to the power of the AI and its ability to generate highly convincing but inaccurate basically content. Probably all of you basically experienced working with ChatGPT, and you know that sometimes if you're expert, sometimes if you ask some question, you'll see that you get an answer that seems very legitimate, seems very accurate, but if you are an expert in that specific field, you could say that this is nonsense and it doesn't make sense. And if you search in internet, you see that there were lots of different reports about inaccurate and like imaginary responses generated by ChatGPT, and at the same time it was very convincing and people would believe in it. So this power can be misused by cyber criminals to basically launch different type of attack, to mislead people, to create different basically groups and then motivate people to take a specific action. And all of those can be targeted toward a specific type of cyber attack. It could be like campaign or different things. And even with the social engineering attack, you know that criminals need to have like fake profile to be able to get access and connect to the people, and then psychologically they can motivate people to do different things in their own benefit. And for that, you need to create different profile. You need to be able to chat in a different way so people would be convinced that these are different people. So one single person with the power of AI, they can pretend to be many different people with different fake profile. They can chat with many different people at the same time, presenting different personality. And that means one single people can represent a group of people and then target a specific victim, motivate them to take a specific action. So, and all of these again can be misused by cyber criminal to increase the number of successful attacks. And the last one that I wanted to point out is in the zero-day attack, because this is a very critical area. by zero-day attack, it means that the attack that is taking advantages of a vulnerability in the system, and that vulnerability is basically not known by the owner of the infrastructure, let's say. Again, with the AI, we can do vulnerability analysis a lot faster and more automated, and then take advantage of those vulnerability to write different type of malware, different type of basically code to attack a system. And when everything is automated, the malware itself can write lots of different variation of its own in the real time. It can basically write lots of convincing emails. So if you put all of these things together, you'll see that it's impossible to defend against such a sophisticated and automated type of attack with the existing tools. With a zero-day attack, you might think, okay, if cyber criminal can take advantage of AI to find about vulnerability of the system, why the owner of the infrastructure don't do that? Why peoples in the different organization don't take advantage of AI to find the vulnerability and then maybe secure them and then be prepared to take to defend against the cyber attack? The unfortunate, let's say, a reason is that when it comes to cybersecurity, it's very, very difficult to convince people to pay for something that they didn't suffer from yet. I've been in lots of different, basically, infrastructure. When we talk with the people, even critical infrastructure like oil and gas, smart grid, transportation, when you talk with them about cybersecurity, they're like, we have lots of other priority that will give us benefit directly. But with the cybersecurity, we don't have enough money to invest in it. So they don't invest proper and amount of money to do vulnerability analysis to be prepared. But on the other side, from cyber criminal perspective, a vulnerability means basically resources that they can use and get money out of it or to get to their basically goal. So they will invest, they will take advantage of AI to do the vulnerability analysis. And again, they're one step ahead of us. But obviously, if organization put enough budget for the cybersecurity to do take advantage of AI, do all the vulnerability analysis, and be prepared, we can reduce the number of successful attacks. So we need to change our approach. We need AI to defend against AI. And that's basically the proper way that we might be able to survive. So in the next couple of slides, I wanted to go through some of the basically different way that we have to change our approach, or we can take advantage of AI to be able to compete. So the general basically answer, or one of the general approaches that we have to take, is to go from a reactive to predictive approach, proactive and predictive security measures. With the traditional security, we have to wait until after an attack happens. Once the attack happens, we have to figure out, okay, what's wrong, which part of the system is damaged, so we will fix it, and we will make sure that the system go back to the normal operation. But in the age of the AI, with the AI-driven threats, waiting is losing, because we have to be able to predict what would happen. Everything is going really fast, and if we cannot predict, we don't have enough time to basically defend against it. So with the predictive security, we use AI, simulation, basically any other tools to predict and forecast that how an attack can happen, in which part of the system the attack can happen, even during the attack in real time. If I have attack in my substation, what other substation might be attacked, so I can basically isolate them, or how the attacker would propagate the attack in the system. All this information with detailed analysis with the AI, you would be able to find all this information, and then you can take proper action. The other basically area that AI can help us is through autonomous threat hunting and threat intelligence. With the threat hunting and threat intelligence, we are not just monitoring the system. Traditionally, when you detect an attack, you know the list of basically possible type of attack, and then you develop different model that can distinguish between the normal trend of the system from those basically suspicious behavior that is from a specific attack. But this is obviously not enough, because with the AI, we can have lots of different variation of the malware very fast in a real time. And then there are lots of vulnerability that can be taken basically into account by the criminals and launch different type of zero-day attack. So just detection is not enough. And by threat hunting, we mean continuously and dynamically monitoring the whole point and whole network data in the system, with the assumption that something is going wrong. And with the threat intelligence, it means that we wanted to collect all the intelligence data available through the website or different platforms that share the data, and we wanted to feed those to our system. Obviously, something like this is very, very large scale, very complicated, and it's impossible with the human resources or traditional tools. But AI, it can be very basically helpful here, because it can extract lots of hidden basically relationship. It can extract lots of features and do an in-depth analysis. So that's the other way that we can always dynamically check the system to make sure that if any suspicious behavior is going on, if it's the answer is yes, then we can do in-depth analysis to prevent the attack. And again, something like that was the proper tool that could help in the case of the Ukraine attack, could help to stop the attack, because as I mentioned, and you can see it in the forensic report for the attack, it's publicly available. The attacker were in the system for 6 months, because the smart grid is very, very complicated system, and it's impossible from outside to know how the architecture of the system looks like. The attacker were in the system, they were launching different type of small attack, and they were observing how the crew fixed those basically fault or damages in the system. After 6 months, they were able to get a proper picture of the system, the number of substations, the tools that they're using, and lots of valuable information. Obviously, if we had such a tools in the system, in the facility, they could see that there is something wrong. We see a physical damage, but when we send the crew, there is no damage in the system. We see suspicious login from some other country in the middle of the night. So, and there are some fault in the system happening at the same time. So there are lots of information that was basically missed to be recorded or to be analyzed. And with tools like threat hunting, we would be able to analyze all those information and then prevent the attack. The other area or the approach that we have to take to be able to complete this AI-based attack is through digital twins modeling. With the digital twin, if you wanted to get a better idea, just imagine that you have a real-time replica of your entire IT or OT infrastructure. Every single devices, servers, network, data layers, everything. If you have all this information modeled as a digital twin of the system, you can simulate lots of different scenarios. You can analyze vulnerability of the system without paying huge amount of money, without damaging any equipment. And even in terms of the during the attack, you have enough time to simulate and see how the attack will propagate in the system through your digital twin. So that also helps you to be prepared. And just imagine how powerful it will be when you add AI also to the digital twin, so it can take advantage of AI for lots of different analysis. This is also another approach that lots of basically people and researchers are taking to be able to compete and defend against attack. The other area that we can take advantage of, and we have to basically change our approach in the way that we're dealing with it right now, is through incident response. Because AI obviously can help us to respond to the attack and to mitigate it a lot faster. Just think of an AI playbook as a step-by-step emergency plan, but fully automated. Something that has lots of knowledge, know the system very, very well, and knows how a specific action can propagate in the system. If you have something by your side, you would be able to take proper decision in the limited amount of time. Because what happens right now in many organizations is that even if you have a very basically senior staff with lots of experience, still they are human. They can make mistake in time of crisis. And the other issue is that many organizations cannot afford to have basically very experienced staff, because we don't have that many people with the cybersecurity, IT, and OT knowledge, someone that can take care of everything and can have a big picture. We already have shortage in the number of cybersecurity experts, number of AI experts. So imagine that you're looking for someone who has knowledge both in cybersecurity and AI and IT and OT. It's very difficult. And we can compete with the attack only if we have such a team that can work together. And the other problem is that I hear from lots of organizations is that we invest in someone, they're very well and they're able to manage our system, but after a few years they would leave. So we have no one, and then we have to hire someone that a specific person don't have that much experience. So we will suffer from lots of attack because they're not experienced enough. So all these can be solved if we have AI next to us that can help us to make the right decision, or can train us as a new employee. AI can train you because it has all the record of all other employees, the way that the organization works, everything about the history of the system. So that's also very valuable. And that's one of the tools that lots of different large organizations are looking for it, to have something in their control center to learn and then later train their staff. But again, this is not something easy to build. And the other thing that we have to basically make sure that we won't forget about is that technology alone won't save us in this situation. We also have to invest in the peoples. And by investing in the peoples, one could mean that we have to basically raise awareness and basically train them to know about the security measures and different things. But the other way that we have to invest in people is through ethics, cultures, and teaching them the right way of product development. Because if our engineers or AI specialists, if they are trained in the fundamental, they know that they have to basically develop tools that is ethical at the same time, fundamentally. Because if ethics is not involved in the development, that the tool can be easily misused and then can be used against us. We have to train our engineers to keep all these factors in mind when they design something. They have to know that security should be there from the design level. Right now, what's happening is that ethics, privacy, security, all of these are an afterthought. We develop something without thinking about any of these, and then we wanted to make it secure, make it ethical, preserve privacy, but it's not going to work that way. Everything should be done fundamentally. And for that, we need to train people, those people who are going to make these basically tools for us. And that's a piece that most of the time people forget about it. And the last suggestion that lots of people are using, again, to compete this AI-based attack is through zero trust architecture. With the zero trust architecture, our goal is to don't trust anything in the system, any device, any users, any system. Everything should be authenticated every single times. And we wanted to make sure that we will give least privileges to people, and we wanted to continuously monitor this. The approach is very basically good, but again, something like this, when we talk about large organization, it's impossible without the power of the AI. So it's like, again, combination of changing an approach and helps using AI to be able to defend. And there are lots of other approaches that we can take. I try to add the most important one here. And to give you a general idea, I've talked about lots of things in terms of using AI for cybersecurity. I thought it might be good to have like one or two examples of the system that we developed, which is used for the cybersecurity with the power of AI. This is an example of work that we basically did as part of a project for the Department of National Defense, and our goal was to develop APT, Advanced Persistent Threat Attribution systems. With the threat attribution, we means that we wanted to figure out what specific type of attack we're dealing. It's more than just detecting an attack in the system. We wanted to know what's the type of the attack, what's the family of the attack, and what's the attacker group behind it. Because we have different well-known attackers group, and each of them have their own tactic, technique, and procedure. And it's very important for the security specialists to know who's behind the attack, because they have different approaches, and that makes it easier to predict what would be the next step of the attacker. So how we can prevent the attack from propagating in the system, or how we can defend against them. This is something very important, but at the same time very difficult, because attacker can easily pretend to be from another group. They can wrap around their code with another header or opcode, bytecode, anything. They can change lots of different things and then pretend to be from another group. They can use the IP address from a different country. So it's very difficult and very detailed and complex task to do. And at the same time, because we are talking about a different group of people that pretending to be from another group, it's always difficult to say 100% an attack belongs to a specific group. So there are uncertainty in the in this type of threat attribution that makes it more difficult. So what we proposed here, which was different from other approach, was that we try to combine both deep learning model with the fuzzy machine that deals with the uncertainty. I cannot add too much details because that was a funded project by DND, but the whole idea was that we combine deep learning and fuzzy learning, and we were able to collect data from lots of different views of the system, all layers of the system. And as you see here in the left side, that we have a single view, we have lots of mistakes in the detecting and attributing of the attack. But in the other one, which is related to the multi-view, you see that majority of the attack was attributed to the right group. I also included the general view of the platform that we developed, and you see that the way that it was working was when we had a specific type of attack, it could give us a general view of what part of the word it belongs to, with this different probability. For example, with higher probability it belongs to APT 33, or with medium probability it belongs to another attack. And for each specific group, it's recommended a specific action to take. So that means, and that would be up to the operators and security specialists to make a decision that if he wanted to consider all of these attacker group, or wanted to give priority based on their budget, based on the time limits, lots of different factors. They could think and figure out which one is the right one to choose and which recommendation they wanted to take. And for that, we received lots of positive comment, and it was very successfully implemented in their infrastructure. So the general approach that we are taking right now is that when we build something, we try to use real-time simulator to simulate the actual environment as much as possible. If not possible, we use different emulator and different software to simulate or emulate the behavior of the rest of the network or rest of the component in the system. And then we use those information to launch different type of attack, and then collect data, and then build different system, and then test our system. Once we're done, and then we will ask different infrastructure to test our tool in an isolated environment to be able to customize and fine tune it. This is the general approach that we are taking in our lab. So I've talked a lot about AI is good. We can use AI for cybersecurity, blah, blah. And most of the time, when I see it in lots of different AI community, that people think that, okay, since we have AI, since we're developing AI, we can solve all the problem in the world, and everyone else can take advantage of it. It's like everyone needs AI, but AI does not need anyone. But the assumption is very wrong, because if you look at the world of AI without cybersecurity, it's like a world of chaos. Without a proper security foundation in the AI systems, AI model can be easily attacked and they can mislead people. They can result in lots of catastrophic damages. So if we wanted to pick one single thing that AI needs is cybersecurity. And by that, I don't mean to build the AI model and then put it in a framework, add different components to make it secure. This is not something that helps. This is the approach that we are taking right now, because we don't have enough experts with AI and cybersecurity training, so they can fundamentally develop secure model. Right now, AI people develop AI, cybersecurity people will embed it in a framework, and then they will add lots of different layers to make it secure. But that's not the right way. The right approach is to make sure that cyber experts also will take an important role in the development of the AI, because AI developers focus on model architecture, training performance, accuracy. But securing AI system requires a different skill set. It requires identifying vulnerability for data poisoning, for adversarial attack. It requires secure data integration pipeline, threat modeling, lots of different things that is expertise of the cybersecurity people. So we have to make sure that we join these two groups of people and they are working together. And that way, we might be able to develop tools that properly can defend against cyber criminal. So to wrap up, I would say the future of AI and cybersecurity doesn't have to be something that we fear. We have to be prepared for it. Obviously, there are risks. Obviously, it's scary and the risks are real, but the future, it's not about eliminating risk. We're not able to eliminate the risks. It's about transforming the risks into resilience. And by that, we means that more than surviving, it means anticipating disruption, simulating different type of attack, automating the whole defense purposes. And this is basically, this means building a system that anticipate, not just react, anticipate and can predict what would happen in the future. The system that explain themselves so people would trust them to implement them. Right now, we have lots of different AI tools, but it's like a black box. When it comes to critical system, people, it's not easy for the people to trust these tools. So we have to make sure that the tools would be explainable and trustable. And finally, this is not a task of technology alone. It needs lots of different people to be basically working together in different levels to be able to basically compete and survive. And thank you very much for your attention. I would be happy to answer any question if you have.
Thank you very much, Professor Karimi Pu. Let's see whether we have any question from audience.
Sure.
Yeah. It seems we don't have a question from audience then. Maybe I can ask a couple of questions.
Sure.
Yeah, so my first question, you mentioned like we can use digital twin as a potential solution for the cybersecurity for AI. So then what are the main technical challenges in building digital twin sophisticated enough to, let's say, detect AI generated content manipulation from the internet?
Yeah, honestly, one of the main challenges when it comes to digital twins, aside from the fact that people need enough budget to invest in it and it's difficult to convince people, is the fact that right now, when we are talking about cyber physical system, we are talking about very, very, very complicated system, very complex with lots of different interconnectivity. If it was like 10 years, 20 years ago, we would say we would be able to mathematically model every single component of the system, and then we can connect them, and then we would have a digital replica of the system. But right now, there are lots of different interconnectivity in different layers of the system. So some of it is easy to fix. If you cannot model the system, you will model something like an AI model or black box that represent that specific component of the system. But right now, I think one of the main issues is the connectivity. The fact that there are lots of different interconnection between different components of the system, and even people who are working in an organization, sometimes they don't have proper visibility over this. So to be able to have a big picture of the system, model everything, this is something challenging. It's not impossible, but very difficult and challenging because of the complexity of the system and many different layers that are working. So it's not something that people can do in a few months or even a couple of years. It needs huge investment, step by step, maybe start from a specific substation in a system, and then after a while they can have a big picture. I see many different big company claiming to have digital twin, but when you go deep through it, when you talk to their expert, you'll see no, they don't have proper one. Lots of it is like a black box, assuming that these specific substation, group of substation represent this simple behavior. It's like with simplicity. So it's a challenge that people are working on it, but it's mainly because of the complexity of the system.
Yeah, thank you very much.
I have a
And
question
also,
if time allows.
sorry?
Can you hear me? I have a question for the
Yeah,
professor.
please go ahead. Please go ahead.
Yeah, I just want to get more information about the project that you presented about the ML-aided threat attribution. So, do you have any publications out of that project so we can, read more, get more information?
I don't have direct publication for that because that was funded by Department of National Defense and they won't allow you to publish. But we have other paper that was out of this that if you search my Google Scholar, you see that there are some papers related to threat attribution. Those are similar to this one, but obviously because that was a project that we delivered, we were not able to directly publish all the results. But for threat attribution, threat hunting, all of this, yeah, if you check my Google Scholar, there are lots of different papers that me and my PhD student we published, and I would be happy to chat with you if you need any help, if you wanted to do similar work.
Yes, of course, because I tried to avoid asking for a proposal or any direct documents out of the project because I know in terms of security. But yeah, that would be great if you share any publications. I will look into your Google Scholar, of course.
Yeah, sure. And if you couldn't find it, all of them are available publicly. But in case you couldn't find, you can email me and I will share it with you.
Great, thank you so much.
Yeah, thank you. Okay, so I saw some questions from our audience. So the first question, with many AI models operating as black box, how do you maintain analysis trust and satisfy regulatory requirements for explainability?
Yeah, I agree that we have lots of different AI models that are black box, but majority of them, if we make it a mandate and rule by government for auditing the AI tools, they're not going to be able to pass this. And we don't have, at least in Canada, I know in US there might be a couple of more rules around usage of AI and how to basically audit it. But generally, all around the world, we don't have that strict, basically, or proper or clearly explained rule around this audit, how to audit AI, how frequently it could be AI, how explainable they should be. But generally, community people are moving toward the fact, believing that model should be explainable, and that's why that lots of people are arguing that we should not just use deep learning because deep learning is powerful, but it's not explainable at all. So they are a specific group of people who are trying to add other component to deep model to make it explainable, or add different features to make the whole model explainable. Obviously, if it's not explainable, it would be very difficult. With a black box, it would be very difficult. If it cannot explain itself, you don't know how it makes decision, so you don't know if it's a wrong way of decision making or right way of decision making, and then you cannot set any rules or basically regulation around it. So obviously, at the time that we have proper mechanism, people have to make their model explainable. Otherwise, it's not going to pass. And critical infrastructure sector that I'm working a lot with them all around the world, they're not going to trust to basically implement these tools, because if it's not explainable, they would say it's just a guess and we cannot just work on a guess to make a decision, because if it's wrong, then the damage would be huge. If it's in different sectors, like if it's related to just a simple IT analysis, it's easy. The worst case scenario is that you might lose internet connectivity, something like that. But when you talk about oil and gas, when you talk about healthcare system, people won't allow these systems to be implemented unless they are explainable enough. So those black box, they're not going to be implemented in the critical sectors. Maybe some sectors that don't want to invest that much, they don't care about basically regulation, and they just wanted to use for some everyday purposes in their business. They can survive and use it. But for the critical sectors, they have to make sure that it's explainable. Black box won't work.
Yeah, thank you. Thank you
Okay, so can I ask a question? So for cybersecurity, accuracy and explainability and anyway, assurance, that's actually the basic requirement. So based on what I heard from you, it seems like the research on along the line for combining cybersecurity, AI, machine learning, whatever. So it's a more goes into the direction of case by case, and also hard to explain of the accuracy. So in this case, I have the big trouble that for whenever just the external people trying to evaluate the trustfulness of the result, then the evaluation criteria is very high. So if we keep doing things case by case, then we probably get into a dead end. Is there any suggestion to be able to explain, what will be the more systematic approach of, being able to produce the more trustful results?
If I understand you, I will answer what I understood. But if I didn't answer your question, please correct me. What I think should happen is that we are not going to be able to build one cybersecurity tools that works in different sectors, is explainable enough or trustable enough that works for different sectors, because every different sectors have different architecture, different requirement, different priority. So I believe that tools should be built for each specific sector or organization, customized enough to know their architecture, their requirement, and everything. And obviously, how we make it explainable, part of it would be general fundamentally, and part of it would be related to what information we can collect from that specific sectors, how visible their asset is, how much information we can collect about the process and everything. Because if everything is more clear, we have more information and we have linked things better, and our AI model can explain it better. But generally, if you're looking for a general approach, I think that would be from AI basically expert. When they develop something, fundamentally, they have to make sure that the tools and the model that they're developing is also explainable enough. If the model is explainable, fundamentally, obviously for us, when we take advantages of it to develop different cybersecurity tools, that's also a basically helpful asset and makes our tools also explainable. Otherwise, it's honestly case by case. That's what I see when we develop something for an oil and gas, or for a small organization, for an insurance company, for a energy sector. We have different type of flexibility over how much information we have and how much we can extract. And obviously, the more information you can extract, the more information you can provide about possibility of the way that the AI is making decision out of those information. So it's really, really difficult. But I think it requires fundamentally, basically fundamental thought from the AI developer to make the tools explainable. And that was something that they were not caring about like 10 years ago or something. Lots of different tools that are developed so far are not explainable at all. But I see trends of the group of people that are working toward explainability. I agree that most of the work that is done is very naive. It's just like several different tools that look at the feature of the feature of the data, and they say, okay, these features are basically highlighted in the decision, then probably the decision is related to these specific features. But that's not explainable enough when it comes to the critical sector. So we also need experts, cyber experts, and engineers engineers from those specific infrastructure to sit together. All these group of people have to work together, and that way we can build something which is explainable. For me, as an AI expert, I see features with higher probability. To me, it means I explain it that these features are the one that I'm making decision. An engineer would look at, okay, this feature, how it's related to the speed of the motor, for example, how it's related to the pressure. They will translate it differently. So it requires group of people to work and then translate it in a meaningful way to be able to use it and explain it. I don't know if I could answer your question or not.
I see. Thank you. But anyway, so it seems like, continue to work along this, direction. It seems, a lot of, more detail-oriented discussions and also more thoughts rather than, also, working in the academic environment, the timing, the pressure is also pretty high.
Yeah.
So, we really, would like to see whether there is any good approach to be able to ensure the timely productivity. Otherwise, everybody will just end up in trouble.
Yeah, I agree.
Yeah. Okay, thank you. I
Thank
hear.
Yeah, thank you, thank you. So maybe we can ask one more question from our audience. So the question is, you touched on the potential misuse of generative AI model like GPT in cyber attacks. Could you expand on some of the key safeguards or detection mechanism that organizations, particularly those in critical infrastructure, should consider implementing to help mitigate these kind of risks?
Honestly, when it comes to generative AI, you can take two approaches. One approach is from the AI community and maybe cybersecurity community. We also have some project in our group that we are trying to make the generative AI model like ChatGPT, large language model, to make them secure. We're trying to figure out what's the vulnerability of those tools and make them more secure. So one thing would be that those security measures or those basically framework would be used along with the GPT architecture if they're using in the organization, rather than just logging to their ChatGPT account, adding all the information. The mistake that lots of people, like I think it was from Microsoft, that they did last year, and it resulted in lots of damages. So they are add-on tools that you can add to the ChatGPT in your organization or other tools that you're using to make it more secure, or some training to teach your employee how to use it. Don't add too much sensitive information or any private information about the company and things like that. So one approach is related to how make these tools more secure and how to train the employee. But the other approach is considering the fact that because of these generative AI tools, you face huge number of the attack. So the probability of being attacked is more. So you have to take it more serious. And again, that's what we see. I had people from Suncor, from several other different infrastructure reaching out to us compared to several years ago that we were trying to convince them. They are convinced now that they need tools because of this huge number of the attack. So they are trying now to invest, to use AI tools and different approaches for the cybersecurity to be able to compete. So we don't have any specific tools or one single solution to implement and then basically compete. It's like several different approaches that you have to take.
Yeah, thank you very much. Thank you. Yeah, so thank you, Professor Karimi Pu. So thank you for your time and the valuable contribution to our webinar. We truly appreciate it.
Thank you very much for your invitation.
Yeah, and the recording will also be available on YouTube channel, and we will send you the link so you can also share it with your network.
Sure. Thank you.
Yeah, this has been a highly informative session, and your insights and will be very useful for our audience.
Thanks. I'm glad to hear that.
Yeah, and let's stay in touch, and thank you again.
Sure.
Yeah.
Have a good day.
Yeah. Take care, everyone. Bye. Yeah.